Okay, I want to talk to you guys about something that we can use Pythagoras for while we're working with linear equations and inequalities and all that sort of stuff that we're about to move into. If you wanted to find the distance between these 2 points, A and B, as you can see, you haven't really been given much information about anything. You can assume that coming down to here, this would be x1, and coming down to here would be x2, and that would be y1, and then that one would be y2. Okay, so we've got some points that are marked on the graph, but it doesn't really help us to determine the distance between A and B. So what would actually help is to, firstly, to draw that in, but to imagine that we are looking at a triangle. If you imagine that we have our triangle along here, it's a right-angled triangle, as you can see. Now that right-angled triangle that we can imagine that is there, well, that helps us out. If this is point C, we'll just call that imaginary point C. Well, AB is now the hypotenuse of that triangle. Okay, so AC is the base, BC is the height. So we know, using Pythagoras' theorem, that C squared equals B squared plus A squared. Well, because we know that, we can actually determine what the hypotenuse length is using this formula. So, what does the B squared equal? Or what does the A squared equal? Well, in this regard, we need to look at the lines that would be associated with each of those, because we don't really know. So we're going to have to leave that as unknowns as yet. And let's look at what we do know. We do know that the distance AC, so the line AC, is equal to the distance between x2 and x1. So if we say that it is x2 minus x1, then that's that distance. We can say that the line BC is equal to the distance between the two y-axes, the two y measurements that we have. So it would be y2 minus y1. So we can now use this here to help us to figure out what is our B squared. So this side is really this BC. So it's not unknown anymore. It's y2 minus y1 squared. And this one then would be x2 minus x1 squared. So, using this information, we can plug this back into our formula for Pythagoras. I've got a bit of a mess, so I'll put it over here, on this side here. So, we know that that is the formula. That's the formula for Pythagoras. So let's substitute what we know. AB is that side. So AB squared will be equal to AC squared plus BC squared. So that side and that side, if we square them, that will equal the distance of that hypotenuse squared. So we can now, basically, if we rearrange things, we will be able to get rid of the squared on this side and say that the line AB is actually equal to the square root of AC squared plus BC squared. And that's a way that you can actually use Pythagoras to find the distance between 2 points on a linear graph, which is pretty handy. That's all.